made mention of both of us because this is a course that she would traditionally teach. Great. So moving right on. I want to start by defining the word neoplasia. And the word neoplasia is a compound word with neo and plasia. And put simply, neoplasia means a new growth. And within the context of pathophysiology, or the things that we're talking about, neoplasia would be a new, uncontrolled, uncoordinated growth of tissue that is not under any physiological control. And neoplasia can be benign or they can be malignant. And when a neoplasia is said to be malignant, then it is cancerous. But we shall talk a bit more about these terms benign and malignant. So neoplasms are also referred to as tumors. So therefore tumors can either be benign or they can be malignant. And we shall talk a bit more about what that means. Cancer is defined as a large group of diseases that can start in almost any organ or tissue of the body when abnormal cells grow uncontrollably and go beyond their usual boundaries to invade adjoining parts of the body and or to spread to other organs. So whenever a tumor or a neoplasia is called cancerous, it means that it has migrated from where it began and has probably spread to other parts of the body. But we shall talk more about this again later. And then oncology is a branch of medicine that specializes in the diagnosis and treatment of cancers. So when we hear the word oncology, it's talking about the study of cancers, in essence, put simply. Another word that we want to define right from the outset is the word metastasis. Well, it varies. Others would say metastasis, but I'll call it metastasis. And this basically is the development of secondary malignant growths at a distant site from the primary site of a cancer. So for example, if a cancer is starting here, as we can see, this is somewhere in the GIT, and then the cancer is found to have spread to the liver as well as to the lungs. That is what is referred to as metastasis or metastasis. statistics and coming closer to home. So in the year 2019, according to a WHO publication, cancer was the first or second leading cause of death before the age of 70 years in 112 of the 183 countries where data was available. That's actually pretty significant. And in Zimbabwe, coming home, the National Zimbabwe National Cancer Registry approximates that every year we have approximately 7,000 new cancer cases each year. That's pretty significant. And then looking at Zimbabwe, the top 5 cancers in men and women are as follows. So in men, the top most cancer is prostate cancer. And in women, it's cancer of the cervix. And then afterwards, in men, we have Kaposi sarcoma, non-Hodgkin's lymphomas, gastrointestinal and liver cancers. And in women, it is listed down there. And then for pediatrics, who are a special population with their own different demographics as well as patterns in epidemiology, the most common cancers are actually leukemias, lymphomas, nephroblastoma, retinoblastoma, and soft tissue sarcomas. And just looking at cancer as a cause of death, we would be here in the red area, where in our nations it's between the 5th and 6th cause of death, or thereabout. Can see this very clearly. But you see that in the so-called developed countries of the world, or the Western countries, cancer is either the leading cause or the second most leading cause of death. Is shown by this blue coloration. And then moving on to just another good heat map, looking at the issues of cancer mortality. Having a look at the top map looks at cancer mortality in males. And if you see Zimbabwe here, we are green, and green there is prostate cancer. So in Zimbabwe, in terms of mortality from cancers, most men actually die as a result of prostate cancer, which is why we're green here. But then looking elsewhere in the world, it seems like most of the people die from lung cancer, which could be probably related to the issue of heavy smoking. And then coming to females, we are here in the orange zone. Most people who die from cancer die from cancer of the cervix in our own setting. But elsewhere in the world, these are pink areas, there seems to be more deaths which are actually related to breast cancer. Okay, so now that we've talked a bit about the epidemiology, the patterns of cancer, we now want to get into the pathophysiology, the pathophysiological issues, which is probably what this lecture is supposed to be all about. But really, before zoning in on cancer itself, we need to get back to some basics with regards to basics of cell biology, which all students by now should have done, either at A level or in physiology or other related courses. So concerning the cell, it's important to know that the cell, cell growth or the production of cells in the body, it's a very intricate process. And as I've put it here, the body keeps an intricate balance between new cells which are being produced and old cells which are dying. If cells continued being produced without some dying, would continue growing and growing and growing and growing and growing. But that's not the way that the body has been designed. So as cells age, they die, and then newer ones take their places. And the way that this is done is actually quite intricate and is well controlled by a number of genes, as we shall see. So neoplasms actually occur whenever there is a glitch in the matrix, so to speak, or whenever there's an imbalance between the new cells which are being produced and old cells which are dying. And in these cases where you get neoplasms, some of the cells become rogue, that's what I've put there, and decide not to follow the rules of engagement and therefore outgrow the normal cells and may invade other parts, causing all manner of problems and issues. So these rogue cells normally multiply and grow more, and they grow faster than they are supposed to. So let's just go and remind ourselves with regards to the issue of cell replication. I'm sure everybody has seen this, which is basically the cell cycle, starting somewhere here, although you can start anywhere, where you've got a cell. Some of the cells go into what we call the G0 phase, which is the resting phase. And that's one thing about these neoplastic cells. They do not go into this resting phase. The resting phase is where you've got cells which are now in the body and are doing whatever they're supposed to be doing and not growing anymore. For example, you've got your cells which are in the brain, your brain cells, which do not continue growing and growing, but just remain to do whatever function that they're supposed to do, as well as your liver cells. But cancer cells just continue growing and growing. And if you recall, the cell cycle has got these different phases, where we've got the G1 phase, where there's a bit of growth. And we'll see this again in a later slide, but this is just to jog your memory. There's a G1 phase, there's the S phase where there's DNA synthesis, there's the G2 phase, and then there's the M phase where there's mitosis, and then replication. Okay, move back to this one. This is the mitosis stage. Now you see, so it one cell, now the cells have divided, and they are two. And then probably just getting a bit more in depth with regards to the cell cycle. So we saw the G1 in this particular diagram. The G0 is not there, but then we know that there are some cells which are no longer growing, which are in a resting state. But the G1 phase basically is where most of the growth occurs. And then the S phase, like we said, that's where there's DNA synthesis. And then the G2, there's growth and preparation for mitosis. And then mitosis or cell division occurs here in the M stage. But one thing to note concerning this cycle is that the division of the cells and the growth is under strict control by various genes, which ensure that the cells which are multiply properly and do not have any damage or issues that might result in cancer. So the tight regulation of the process ensures that the dividing cell's DNA is copied properly. And should there be any errors in DNA, this cycle or the process, as well as the genes around, try to ensure that the DNA is repaired. And if the DNA is not repaired, it will then undergo a process known as apoptosis, which I'm sure by now you've heard of, which is basically programmed cell death or self-destruction or cell suicide, where the cell, by virtue of the fact that it might have DNA which has been mutated and is not proper, will, for the benefit of the greater good of the body, kill itself off in that particular process, which is known as apoptosis. And in some instances, cells which then might have some mutations in the DNA sequence can also be killed by the natural killer cells which are found in the body. And then one thing which we'll talk about, I think, in the next slide is that, during the cell cycle, there are several checkpoints that are actually in existence to make sure that ultimately the cell which is replicated comes out well with properly copied DNA to cells there. So as all these things are happening, they are done under the strict control, as we said earlier, of various genes. And there are two major groups of genes which are important with regards to the control of cell growth. The first genes are called proto-oncogenes, or you can think of them as the accelerator genes. Basically, these genes push cell growth and cell division forward. And an example of such proto-oncogenes is the BRCA1 or BRCA1, which is actually very important in the development of breast cancer. So these genes can actually get mutated, the protogenes. And whenever protogenes mutate, they then form what are called oncogenes. And oncogenes are extremely important or play a vital role in the development of cancerous cells, or turning normal cells to become cancerous, or in the neoplastic cascade or mechanism. So remember, oncogenes tend to speed up or stimulate cell division and prevent differentiation or regulate apoptosis. So if something happens to the proto-oncogenes and there's a mutation, then you can have cells which continue to divide, cells which do not become differentiated, cells which do not have programmed cell death. So that's the one hand. And then on the other hand, we've got what in the past were called anti-oncogenes, but have now come to be known as tumor suppressor genes. And you can think of these as the brakes in terms of the cell cycle, or in terms of cell replication and cell division. And these genes, I think the one that student should know of is the famous p53 gene. They basically encode for proteins that restrain inappropriate cell growth and division, and stimulate cell death, and are also involved in DNA repair processes. So you can think of these genes as the brakes, basically trying to stop cells from continuously multiplying or growing. And if there is any mutation in these genes, the tumor suppressor genes, it might lead to inactivity. And you can just imagine inactivity of these tumor suppressor genes would be like a car which does not have any brakes, and therefore neoplasia can actually be stimulated or facilitated. So remember these two, that we've got the proto-oncogenes, which when mutated become oncogenes, which actually accelerate or stimulate cell division, prevent cell differentiation, and may actually prevent apoptosis. And then on the other hand, we've also got the tumor suppressor genes that we refer to as the brakes, which if they mutate through one process or the other, leading to inactivity, could then also facilitate the formation of rogue cells or neoplasia. Hope that makes sense to everybody. So just moving right on, I would like to just say a little bit about this process of apoptosis, which I hope students have had a chance to learn about prior to this. So apoptosis is a process of programmed cell death, which eliminates unwanted cells. So that process starts early, even at the embryonic stage. And for example, if you notice your fingers, we do not have flaps like frogs, but we've got distinct standalone fingers. And it is the process of apoptosis, which ensured that there were no cells which were growing between our fingers in a developing hand. But this apoptosis is also extremely important in adults because it also rids the body of cells that have been damaged beyond repair. And such cells, ordinarily, what the process is trying to guard against is to reproduce cells which have got a DNA sequence which has been mutated, or genes which have been mutated, which could be a hazard to the body or which could actually cause cancers. And just at the top here is just a diagram showing the process of apoptosis, which actually starts from within the cell itself after some signals are given to the cell. And basically the cell shrinks. There's a process of blebbing, nuclear collapse, and then you have apoptotic body formation. And then the macrophages are the ones that would then take these and recycle them. So remember apoptosis, which is extremely important in preventing cancers. So what you find is that cancer cells do not undergo this process of apoptosis. They tend to ignore it because the genes which are supposed to code for apoptosis to start to occur, we saw them earlier, the proto-oncogenes, might have been changed. So therefore it just goes on and on unchecked, and then you've got this rapid cell growth. And then the other thing related to apoptosis, we did mention them earlier, the natural killer cells, which are extremely important. They're a type of immune cell that has granules or little small particles with enzymes that can kill tumor cells or cells infected with a virus. So I've got in this little cartoon there, that's the natural killer cell. And then we've got a healthy cell there. Because the cell is healthy, the activating receptors have nothing attached to them. Therefore, the cell survives, nothing happens to it. But the moment that the natural killer cells come across cells which are abnormal, for example, the cancer cells, and then we've got activation of the cells, which then releases cytotoxic substances, cytokines, which ultimately kill the cell. And one thing that you find now in the case of cancer cells is that this process, they are quite able to actually evade these natural killer cells, thereby multiplying exponentially. So like I said at the beginning, a disturbance in the balance of the things that we talked about above, a disturbance in the balance of promotion of cell growth compared to destruction of old cells, anything that disturbs that balance, normally as a result of mutations in genes that code for proteins that either accelerate cell proliferation or decelerate it or cause cell death or apoptosis. Anything that causes an imbalance to that will then lead to cells which become cancerous or new growths or neoplasms. Hope that makes sense. So I keep talking about mutations, and at this point it might be important for students just to have a revisit of their first year physiology or even biochemistry with regards to the process of replication of DNA. So anything which can cause the DNA base pairs, or the genes. So genes are ordinarily a portion of the DNA which has got certain instructions. Anything that causes a mutation to that will could ultimately lead to a cancer, as we saw earlier. So here I am expecting that students should be able to know, what the role of topoisomerase is, what helicase does, the Okazaki fragment, what that is, what primase is, what ligase does. And if you don't remember these things, please go back and revise them. So in terms of what could go wrong at the level of the DNA or the genes, there are different types of mutations that could occur. A chemical, a virus, whether it's radiation or whatever, could cause deletion of a certain part in the DNA sequence, and therefore leading either to inactivity of a certain gene, or the gene, now coding for different types of proteins as it is compared to what it was supposed to be doing at the beginning. So the major types of mutations that can occur are either deletion, or they can be duplication, or they can be invasion, or they can be insertion or translocation. And it is expected that at least students have an idea concerning these different mechanisms from your biochemistry. All right, so having said that, I just want to talk a little bit about benign versus malignant tumors. So we defined neoplasms as new growths, and we said it was in an uncontrollable growth which was not under the influence of normal physiological systems. So it means that there's a certain portion or a certain part of the body or a tissue where the cells start to multiply in an abnormal manner. But it's not just a matter of multiplication. So let me rephrase it. Let me put it differently. In terms of neoplasia, there can be two types of neoplasia or two types of tumors. The benign tumors or benign neoplasia generally would not be too concerned about, except, as we shall see a bit later, in cases where the abnormal growth in cells is compressing either nearby structures or causing some other problems like that. So these cells ordinarily would just grow in situ wherever they are and would not migrate to other parts of the body. The moment that we define a neoplasia as malignant, this is then what we call a cancer, when the cells or the cancerous cells metastasize and move to other parts of the body. So here I've put 4 key differences between a malignant and a benign cancer. So malignant and a benign tumor, not a cancer. I beg your pardon. So a benign tumor could just be a lump. For example, fibroids in females are benign. They're not expected to, to undergo metastasis, but will remain exactly where they are. The issue is that there's then this increased growth of cells in a particular area. So the major differences between benign and malignant tumors are, in terms of differentiation, I think you would remember differentiation from your cell physiology. So differentiated cells are cells which have, in essence, if I can put in quotes, have a certain character. They are defined cells. So you'd find that in benign tumors, the cells are well differentiated. They've got a proper shape which looks like other normal cells within the body. They might be slightly different here and there, but generally they've got the boundaries which can actually define that this is a cell. Yet when you're looking at malignant tumors, the opposite is true. The cells are not very well differentiated. If you look at these cells, compare these cells with the normal cells, which are the blue cells, which are here, which are basically spherical, but these ones have got a shape like the ghosts from from the Casper, the friendly ghost. Okay, in-house joke. Yeah, so they're not well differentiated. They don't look like the ordinary or normal cells because they're growing too fast, you see, and because they're not following the rules of engagement with regards to cell growth. And cells which are like this tend to grow much more aggressively and much more rapidly and can actually move to other parts of the body. The second thing which differentiates benign and malignant tumors is the rate of growth. Like I said just now, these cells which are not very well differentiated tend to grow much faster than the ordinary ones. But in benign tumors, the cells are well differentiated and therefore tend to grow much slower. So you find that benign tumors do not grow aggressively. Yet malignant tumors, which we have referred to as cancers, actually grow at a much faster rate. And then with regards to benign tumors, there's the issue of local invasion. Benign tumors do not invade other tissues and generally tend to be localized with a very well defined boundary, ordinarily of fibrous tissue around them. Yet malignant tumors or cancers have a tendency to then spread to other areas where they cause more cancers there, and the cascade goes on and on. And then the fourth difference is the issue of metastasis or metastasis, depending on how you want to pronounce it, where malignant tumors spread to other remote parts and form secondary sites, for cancers to actually begin from there. But with benign tumors, they basically remain wherever they are. So I hope you got this difference because this is extremely important. We said neoplasia were new growths, but not all neoplasias are cancerous. In order for cells to be called cancerous, there are some certain characteristics that have to occur. So cancerous cells are not very well differentiated. They've got a rapid rate of growth. They invade tissues apart from where they are, and they move to others. They spread to other parts of the body. Hope that makes sense. But then, having said that, benign tumors are not that innocent, strictly speaking, because the temptation might be there to think, okay, yeah, so if somebody's got a benign tumor, then it's all good. But that's not the case. It's not all the time. For example, if you have a benign tumor which is in the brain, it might cause issues because it might occlude, circulation of blood or occlude some other important parts in the brain. And therefore, even though those tumors are not cancers as such, but if they grow, even without metastasis, they can still, cause significant issues by occluding important or vital areas within the brain. So, although benign tumors don't really cause serious health issues, generally speaking, they may become large enough to start compressing structures nearby or either vital organs, like we have brain tumors, or if you've got one in the chest or in the close to the lung, it would start compressing, your trachea, and then somebody could have difficulties in breathing. But in addition to that, you if these tumors are growing close to hormone-producing glands, you could then either have hypersecretion or hyposecretion of certain hormones, which could cause people to become sick. For example, if you've got pituitary tumors. And also, there are some cases where some tumors start off being benign. For example, your colon polyps, but then over time may actually decide to become rogue and become malignant. So there are cases where your physician might say this growth is nothing to worry about. We can just leave it to go away by itself, or you can just live your life with it. But there are some times whereby it might be necessary for surgery to be done, that it might be cut off or removed from the body. And here I'm just showing you what fibroids are. And fibroids are basically benign tumors in essence, which are just there. Most of the times they wouldn't cause any issues. To be difficult, of course, depending on how big they are, for some ladies to bear children. And at times they grow so much that they become uncomfortable or press on some structures, making producing pain in the woman, where they might actually have to be surgically removed. But otherwise, they're just generally benign. I hope you understood the difference between benign tumors, compared to malignant tumors, which we have referred to as cancers. So concerning benign tumors, I think this is where our discussion on them will probably end. And from this point forth, we want to focus a bit more on the issue of malignant tumors or cancers. So let's talk a bit about cancer. So like I said earlier, cancer cells have got some characteristics, some hallmarks, some things that define them as cancer cells. So a paper was published some years ago, I think 2011 thereabouts, which came up with 6 hallmarks of cancer. A more recent one, I think, has taken this number up to about 10 or so. But these 6, in my opinion, are pretty good because they give a very good broad overview and foundation of things to look out for with regards to the properties of cancer cells. So the first thing, in no order, is that cancerous cells, in order for them to become cancerous, must have self-sufficiency in terms of growth signals. So the cells must be able to produce growth signals for themselves, which are not linked to the growth signals that the body is producing. So like we said, they've become rogue. If it was in the Japanese samurai days, they've become ronins. Ronins who were samurai who did not have any master that they were reporting to. So that's the first thing one of the things that has to be there. One of the properties is that they become self-sufficient in terms of their own growth. So they become a law unto themselves in terms of how they grow. And that's what a cancerous cell should have, is one of the hallmarks. The second thing is they should be insensitive to inhibitory growth signals. Remember, we talked about the tumor suppressor genes. So the tumor suppressor genes would code for proteins which then inhibit growth. But then tumor cells, because they've become rogue, become insensitive to those inhibitory growth signals and continue growing and growing and growing and growing and growing unchecked. And whenever cells have that characteristic together with the others which are listed here, then we can truly define them as tumor cells. The third thing is the ability for the cells to invade other tissues and to go to other parts of the body. Remember, we saw that when we were comparing malignant versus benign tumors. So malignant tumors or cancerous cells have this capacity to invade tissue as well as for metastasis. The fourth one, they must have an unlimited potential to divide. The body, as we saw earlier when we were looking at the cell cycle, produces a number of genes to try and limit growth. And that's the reason why, we just don't continue growing and growing and growing and growing and growing and growing and growing, because the body limits itself. But cancer cells do not have any limit like that. They're like gluttons who just continue eating food and eating and eating and eating and eating and eating until they die. And then the fifth one is angiogenesis. So angiogenesis, angio, talking about blood vessels in essence. The cells must have a capacity to develop their own supply, not develop as such, but let's say develop their own supply of blood, to feed the cell. So what you find is that the cancer cells, which is interestingly where the term cancer came from, it came from a Greek word, kakos or something like that, which means a crab. Because the cells then have these appendages where they attach to, whether it's capillaries, and then start sucking up the supply of blood. And that's what angiogenesis is. They must be able to come up with their own blood supplies to nourish the cells and keep them growing. And then the sixth thing is that the cells must be able to avoid apoptosis. And remember, we talked about the P53, which is the major tumor suppressor gene that we have in the body. And basically, the cells stop listening to p53 or stop listening to whatever proteins have been encoded by p53 and refuse to kill themselves. The cells become selfish and say, to hell with this common good for the body, to hell with that. We are a law unto ourselves. I hope that makes sense. Okay, so just moving on. So the process of carcinogenesis, or the formation of cancers, has it is agreed that generally it's a three-staged process, and the three stages are initiation, promotion, and progression. So even though the mechanism by which cancers occur is not completely understood, we know that exposure to known carcinogens can lead to cancer, but does not necessarily always result in cancer. That's an important fact to consider. Is it because if you remember earlier, the body has got its own mechanisms to actually repair DNA. So if you've got more repair occurring compared to damage, then the likelihood of a cell actually becoming cancerous is much less. So in very healthy people who are eating healthy, etc., exercising, the capacity for repair might actually be much higher than the capacity for damage. But there are some risk factors which are associated with cancer, which we shall talk about. So cancer, carcinogenesis is a multi-stage process that is genetically regulated. So moving on to the first stage. The first stage is the initiation process, and this is when exposure to a carcinogen results in damage to cells. And here the damage to cells that we are really talking about, we're looking at the genetic material. So the damage may be repaired, like I said earlier. However, if it is left alone, it may result in irreversible gene mutations. And the moment that you have irreversible gene mutations, and then the cell starts to multiply, those mutations or the irreversible gene mutations then cause either inactivity of a certain gene related to the cell cycle, then we might start to have some issues. So the mutated cell has an altered response to its environment with a selective growth advantage. Remember what we were talking about, how the non-differentiated cells seem to grow much faster and are more aggressive compared to the ones which are under the watchful eye of the proto-oncogenes as well as the tumor suppressor cells. And then this can develop into clonal populations of neoplastic cells. The second phase is promotion. So it is possible that you get initiation, but initiation by itself without promotion might not actually result in cancer. So promotion involves exposure to carcinogens or environmental factors that promote neoplasm growth. Over the years, before in the past, there was a thought that just initiation was all that was needed, to get cancer going. But in recent times, there have been lots of studies which have actually demonstrated that promoters of cancer are actually equally important, if not more important. So it involves exposure to carcinogens or environmental factors that promote neoplasm growth. So whereas initiation is actually a reversible process, because we said it earlier that there is some repair processes that occur to the damage, but promotion is actually not irreversible. And it's not reversible. So here, what basically we're saying is that the body has a natural repair mechanisms, e.g. proofreading. We talked about this, the checkpoints, as well as even in DNA synthesis, you've got proofreading by DNA polymerase lysis of neoplasms by cytotoxic T cells. We talked about the natural killer cells. And this really can be done at the stage of initiation. So it can take months or years to move from initiation to the promotion stage, and then to clinically detectable disease depending on the type of cancer. So cancers can actually take a pretty significantly long time before they actually appear clinically. We've got some examples of fast-growing cancers. For example, testicular cancer, burkids, and pediatric cancers are generally fast-growing and have a small volume doubling time. On the other hand, breast cancer can take almost 3 years, before it becomes clinical. And prostate cancer is also a slow-growing cancer, as well as colon cancer. These are slow-growing cancers. So remember what? The slow-growing cancers, as well as the fast-growing cancers. Testicular cancer, fast. Pediatric cancers, fast-growing. Breast cancer, prostate cancer, and colon cancer, slow-growing. Then the final stage or final phase in carcinogenesis or in cancer formation is progression, which involves further genetic changes which lead to increased cell proliferation. So actually you find that cancer cells don't really look alike. Okay, look at this. This is a cancerous cell, which is bluish. But then we have other cancer cells, the ones which ultimately migrate, which don't really look like these ones. And that's the issue that we're talking about, differentiation. That the cancer cells, even amongst themselves, do not even look alike, because as time proceeds, they, form other cancer cells which are more heavily mutated than the earlier ones, and therefore are less differentiated. And these are the ones which have got the ability to move to other parts of the body. So the critical element for this stage in terms of progression is tissue invasion of local tissue, as well as the development of metastasis. I hope that makes sense. So we've got initiation, we've got promotion, and we've got progression in terms of the stages of cancer. And I like this. This was put by my colleague Pinky, that in the initiation stage you get mutagenic agents. So mutagenic agents are any agents which have got the ability to alter the genetic material. And you can have inherited factors. So there are some cancers which are actually inherited. I think retinoblasts is an example, especially those that you find in children. And then you get some viruses which can actually cause cancers in themselves. You have some chemicals as well as radiation. Then we have the promotion stage, which is also involves mutagenic agents like chemicals, radiation, and your viruses. Here we don't talk about the inherited factors anymore. And then progression is when now the cancer has become malignant and is moving to some other places. Interestingly, the word malignant means evil. Okay, all right. So moving right on. So is everybody at the same risk of cancer? Well, not necessarily. There are some risk factors. We did talk about these earlier when I was giving the WHO fact sheet. I think here are some of the risk factors for cancer. So the first one is being old. And obviously, the older you become, there's a number of reasons which are associated, with this particular one, including telomeres, that the telomeres are now much smaller, so the likelihood of some genetic sequence, damage or mutations are much higher. But also, your body mechanisms might slow down a bit in terms of, what is required to slow down the growth of the cells and other things. And that's why cancers generally are much higher in older age. And then the issue of family history. You can have some mutations which are in recessive genes, and then if you have two, a mother and a father coming together with those recessive genes, and they come together, then the cancer might actually show up in the child. And then using tobacco, this we know about. I mean, lung cancer. Obesity is a major issue as well in terms of the repair mechanism. There's some theories which have to do with insulin resistance and other things like that. Alcohol consumption as well is a risk factor, as well as some viruses which we have talked about, like the human papilloma virus, as well as some specific chemicals, some of which I think we'll talk about in the next slide in passing, as well as exposure to radiation, including ultraviolet radiation from the sun. And this is largely related to issues of skin cancers. So, in terms of carcinogens, exposure to chemicals may occur by virtue of occupational or environmental means. Um, in recent years, there have been some interesting stories, where former workers at asbestos mines who died from lung cancer or have lung cancer have had to be what's that word? Had to be paid for the pain that they suffered, for the cancers that they got from working there. So some occupations actually, predispose people more to cancer compared to others. But there's other certain chemicals that you know of. Here I talked about asbestos, but then we know that aniline dyes, benzene causes leukemia, and some other drugs and hormones can actually lead to carcinogenesis. I think over the past few years, a couple of years, there's been this nitrosamine issue, where a number of medicines have been pulled off the market after being found with high levels of nitrosamines, which are in themselves carcinogenic substances. And then we've got cigarette smoke, which contains aromatic compounds which are carcinogenic, as well as cadmium in there. Physical agents like ultraviolet light, and especially ionizing radiation can cause cancer because it can knock out an electron. And for those who did chemistry, your whole free radicals, which can actually go and bind to cellular components, causing gene mutations. And then we also get viruses like the Epstein-Barr virus, which is believed to be an important factor in Burkitt's lymphoma, which we see largely in children. And then we've got herpes simplex virus 8, which is important in the formation of Kaposi sarcoma. Hepatitis B, which is important in liver cancer, as well as the human papilloma virus in cervical cancer. And actually, that's the reason why we have young ladies or young girls being vaccinated against this virus to try and deal with this problem of cervical cancer. And then HIV positive patients are more likely to develop a non-AIDS defining malignancy, and this is thought to be due to chronic inflammation, because some inflammatory mediators actually play a role in the proliferation of cancer cells. So cancer is actually linked. Some cancers are linked to chronic inflammation. And then just a bit about the issue of tumor growth. So for those who may know or be aware of the recommendations, it is recommended that the tumors should be treated as soon as possible, and that's because they have this exponential growth that occurs. That if you take time, to start treatment, within a short period of time, the tumor or the cells would have multiplied at an exponential rate. So in the early stages of growth, it is exponential. It's characterized by what's called a Gompezian growth curve. So most chemotherapy is more effective for smaller tumors, as well as surgery would be good before the tumor goes beyond the tissue. And when the tumor is still small, before angiogenesis occurs, it can actually be chopped off and may not grow. And that's why surgery becomes important like that. And then as the tumor grows, the doubling time is slowed. So by the time you get here, most of the times the tumor is probably spread all over the body. And then onto some basic nomenclature with regards to cancers or tumors. It's like we said earlier. We saw this from our WHO definition of what a cancer is. That cancers can arise from any tissue. As a general rule, when we have an oma at the end um, of be it a tissue, a gland, it normally denotes, benign tumors. For example, an adenoma would be a benign tumor. The moment that we see carcinoma attached to, a prefix of a body organ, then ordinarily we know that we are dealing with a cancer. All cancers. So the moment that you have carcinoma, you're dealing with a cancer. The moment that you have sarcoma, you're dealing with a cancer. You're no longer dealing with benign tumors. So a carcinoma is normally growths arising from epithelial cells, for example, adenocarcinoma. And then if you've got sarcomas, these are tumors that arise from muscles or connective tissues, for example, Kaposi sarcoma. But again, we should remember that there are exceptions to these rules, and these are just general principles that students maybe must be aware of. But this does not, it's not hard and fast, because there are some which are actually difficult. And then hematological malignancies are classified differences. They're called leukemias, or they're called lymphomas. So students can read more around this, but this is just as a general rule, to guide you with regards to how cancers are named. Okay, so how are cancers diagnosed? So in terms of diagnosis of cancer, there are many methods which are used, which can include scans, MRI scans, CT scans, tissue biopsy, where you take a portion, a little part of the tissue, and then it is examined under a microscope. You can have histology, immunohistochemistry, as well as some tumor markers. For example, PSA is a tumor is a marker for prostate cancer. Not a very accurate one, but well, not a very specific one, but it is nonetheless. And then the other methods of diagnosis, for example, there is the visual inspection with acetic acid, which can be done. If it's the breast, you can have breast self-examination. Prostate self-examination, not that easy. You probably need to go to a doctor to do it. And with regards to diagnosis, it's important, like I said earlier, that if a cancer can be caught early, ordinarily it can be dealt with. And most cancers are curable by surgery or radiation before they've metastasized. And early diagnosis is difficult for most cancers, because as they start, they have no clinical signs until they've grown or metastasized to other body parts. Hope that makes sense. Don't worry, we're coming to the end of the lecture soon. So I just want to say a little bit about the issue of tumor staging and grading. I'm sure you've heard people talk about how their cancer is now stage 4, and the person there's a few months to live. So there are two major systems that are actually used in staging. And I want to talk about one major system which is actually used in grading. So staging and grading of cancer, it actually allows medical staff to be able to determine the size of the cancer, and whether it has spread or is spreading, and what the best treatment options are, as well as to compare with other cancers, as well as to provide information which is important for clinical trials. Because actually for clinical trials with drugs, patients who have got terminal illnesses like cancers have got okay, I'm digressing a bit. I'm moving into toxicology. Okay, never mind. So for clinical trials, just know that, and then if you're interested, just read about it. So staging is actually related to how the cancer has spread, and grading has to do with how the cancer cells look like under a microscope. So that's the difference. If I say staging, we're talking about how, the cancer, if we say staging, we talk about how the cancer cell has spread. Stage 4 is bad. If we say grading, and ordinarily for grading is grade 1 to 3, we're talking about how the cancer cell looks under a microscope, how differentiated it is. Does it look like a normal cell? Does it look abnormal? And other things like that. So there are two main types of staging systems which I want to talk about today. The first is called the number staging system, and then the other one is called the TNM staging system. But before we talk about those, let's talk about cancer grading. So like I said, cancer grading talks about how the cell looks like under a microscope, and the grades are from grade 1 to grade 3. I've tried to, I took a cartoon off the internet here. So grade 1, the cells, cancer cells, resemble normal cells and they aren't growing rapidly. So this is what grade 1 would look like in terms of a cartoon or a diagram of the cells. Grade 2, the cancer cells don't look like the normal cells. So these cells don't really look like these cells and are growing faster than the normal cells. And then grade 3, the cancer cells look abnormal. These ones have got a different color altogether. And may grow or spread more rapidly. So this is the grading, cancer grading, which is used by physicians or doctors when talking about cancer or describing cancer. So there's grade 1, looks or resemble normal cells. Grade 2, don't resemble normal cells, have started growing fast. Grade 3 are actually quite abnormal, not quite like the normal cells at all, and they are growing and spreading more rapidly. So that's grading. Remember grading, we're looking at how it looks under a microscope. Okay, and then moving on to staging. So the first staging system that I want to talk about is called the number staging system, and this is a very common one, which even lay people know about. Anybody who's ever had a relative, a friend, or watched a television program which depicts somebody with cancer. So there are basically 5 stages which start from stage 0 to stage 4. So stage 0, the cancer is where it started, and that's like here a picture of it. Stage 0, it's where it started and it hasn't spread. And the word which is used there is in situ, which talks about it being where it started. Stage 1, the cancer is small and hasn't spread anyway. That's stage 1. So if it's stage 1, stage 0, stage 1 can probably be still can be dealt with using chemotherapy or surgery or whatever else. Stage 2, the cancer has grown but hasn't spread. That's stage 2. Much bigger now, we can see it, but it has not spread. Stage 3, the cancer is larger and may have spread to surrounding tissues. You see there it is surrounded to spread to surrounding tissues and or to the lymph nodes. So just generally, cancer cells move through 2 major mechanisms, or through 2 pathways, if I can say that, or routes, either through the blood or through the lymphatic system, because they are cells anyhow. So cells either move through the blood or they move through the lymphatic system. And then stage 4, the cancer has spread from where it started. So here, the cancer is now gone from where it started to at least one other body organ. And it's also known as secondary cancer or metastatic cancer. So these are the 5 stages. So stage 1, the cancer is where it was. Stage 2, the cancer is there but small. Stage 1, the cancer is there but small. Stage 2, it has grown a bit. Stage 3, maybe it has gone to the lymph nodes and surrounding tissue. And stage 4, it's basically gone all over the body. The second staging system is referred to as the TNM staging system, where the T describes the size of the tumor, and the size is described with a number which starts from 1 to 4. So that's T. So this is from a breast cancer perspective. So if it's breast cancer, if the tumor is less than 2 centimeters, that's T1. If the tumor is more than 5 centimeters, T3. If the tumor extends to the skin or the chest wall, then it's T4. Yeah. So there's T. And then N stands for lymph nodes with numbers from 0 to 3, where 0 means there's no lymph node metastasis, so the tumor is not spread to any lymph nodes. And 3 means, many lymph nodes have basically been affected by the tumor. There's been metastasis. And then the M stands for metastasis, or whether the tumor is spread to another body part or not, and is given either as 0 or 1. So this probably just for students to be aware of, not necessarily know it in depth, but be aware of it and be able to discuss it, with your colleagues. And when you come across charts with these, at least have an idea of what the physician is referring to. And then in the final slides, I just want to just have brief overviews on maybe 2 tumors, and then I'll just give you some work for you to look at. So the first one is cervical cancer, which is a very important cancer that we have here in Zimbabwe, the most common cancer among Zimbabwean women. Actually, the leading cause of death, I believe, from cancers here in Zimbabwe, from what we saw from that WHO heat map that we saw at the beginning. And it's normally associated with human papilloma virus, as well as HIV co-infection, and women who have cervical cancer tend to have had earlier sexual debuts. So, people who start indulging in sex quite early have been found to be more at risk compared to those who start later. And also there's the issue of them also having multiple sexual partners. And like I said earlier, there's a vaccine for the virus, which can be taken. So cervical screening can actually assist in terms of morbidity and mortality from this cancer. And the most virulent strains are HPV 16 and 18. So that's one. And then, just an interesting schematic of what happens. So we've got, herpes papilloma virus oncoprotein, which binds to P53. P53 loses inactivity. Remember, P53 we said was the guardian genome, and now because it's no longer doing its job, there's no apoptosis, so the cancer cells keep growing. There's no DNA repair. There's no G1 arrest. Remember the first checkpoint that we talked about, so therefore there's proliferation of the cancerous cells. And then the second cancer which I have here is Kaposi sarcoma, which is the second most common cancer amongst Zimbabwean men, which is characterized by angioprolific multifocal tumors. Can you see? Yeah, so all these, and is caused by a combination of immunodeficiency as well as herpes simplex virus 8 infection. Terrible cancer. Fortunately, over the years, the incidence has gone down because of the antiretroviral drugs that we have. They're highly effective ones. So yeah, those are the 2 that I wanted to highlight. And then in terms of reading, students just read around the issue of breast cancer. Remember we talked about the BRCA1. I think with the pathophysiology that we've been talking about, just read through it, see if you can relate to it. Maybe read something about prostate cancer as well. Nothing too detailed, because I think in terms of the basics of the pathogenesis, the pathophysiological basis, we've covered them. Cervical cancer we've talked a bit about, but read also about it, Kaposi sarcoma, blood cancers, and pediatric cancers. And then the other thing that students should also read about is the different options which are there for the management of cancers, from chemotherapy. You shall cover it, of course, when you do your pharmacology. But just read about it, just know why, chemotherapy. Remember, we said cancers are rapidly dividing cells. So one of the mechanisms for chemotherapeutic drugs is to target rapidly dividing cells. And that's the reason why you find, cancer patients on chemotherapy having hair loss, because, your hair follicles are rapidly dividing. It's the reason why when you shave your beard, after about a week, the beard is back. You know, cryotherapy, surgery, radiation therapy, read around those things. Otherwise, I hope this was an interesting topic for you and that you've actually learned something with regards to cancer. Otherwise, best wishes with the rest of your studies. Thank you very much. At this point, I would like again to acknowledge my colleague, Pinky Manyao, who worked on a number of the slides which I presented today. So thank you very much. Otherwise, goodbye.